Hello, my name is Melvin Cheah and my ID is 18002598, and today I'll be talking about impacts of a jet for my Fluid Mechanics Control Volume Lab 3. So let's get to it. For the introduction, it is to analyze fluid motion. A finite region of fluid control volume is usually selected, and the gross effects of the flow, such as its force or torque on an object, is determined by calculating the net mass rate that flows into and out of the control volume. The equation that will be used in this experiment is the momentum equation. The equations used are B equals Q over A, and as displayed on the right over here, the momentum equation. As for the objectives, it is to investigate the reaction forces produced by the change in momentum of a fluid flow when a jet of water strikes a flat plate or a curved surface. It is also to compare the results from this experiment with the computed forces by applying the momentum equation. For the apparatus and methodology, a hydraulics bench is used. Impacts of a jet apparatus with 3 flow deflectors with deflection angles of 90 and 120 are used. A stopwatch for timing the flow measurement is also used. As shown in figure 1, impact of jet apparatus, the apparatus setup is shown in this picture with the labelings of the parts shown as well. As for the procedure, the apparatus was leveled and the lever was set to the balance position. Water flow was emitted to the supply valve and the flow was increased to the maximum. Flow rate was established by collection of water over a time interval. 8 more readings were recorded as the flow rates reduced, and steps were repeated twice for the flat plate and the hemispherical cup. Over here we have the results from the experiment. Table 1 shows the results for the flat plate and table 2 shows the results for the hemispherical cup. F1 and F2 were calculated from the experiment for both tables. Now for the results part, the tables that were plotted earlier, the data from the tables were used to plot this graph of forces against flow rate. So for this experiment, the values and data were used to determine the shape of the graph and the relationship between forces and the flow rate. As for discussion, as the flow rate increased, the force resulted from the impact of the jet on both the flat plate and the hemispherical cup is increased for the predicted F1 and the measured F2 values of the force. This relation can be seen clearly from the 4 plots accompanied with this report. This result was already predicted from the change in momentum equation of calculating the force. Some errors that might have occurred are errors in taking reading, which might have hindered in the overall accuracy of the experiment. So in conclusion, the impacts of the jet forces on the flat plate, by half of it is on the hemispherical cup. This result is displayed clearly in plots 1 and 2 for both predicted and measured values of the forces. This was already predicted from the equations of momentum for calculating the forces. According to the last point, the hemispherical cup is more efficient while using in a turbine than the flat plate. But only one point is to be considered is that the water to exit the cup is going to collide with water entering the cup, which will reduce the force. That is all. Thank you.